Hello dear students, today a very important question which is important for board exams as well as for the competitive exams. Here your question is, find the volume of solid generated by revolving the area bounded by the curve y equals sin x from x equal to 0 to x equals pi upon 2 about x axis. So see the solution, and before solution, first you should understand it's a graph. Your solution started from here. So first you should understand it's a graphical part, graphical solution. A curve for y equal to sin x, curve for y equal to sin x and varies from 0 to pi upon 2. 0 to pi upon 2. So we should start from origin, that is 0, pi upon 2, consider it is pi upon 2. So it is not pi, it is pi upon 2. We should take here this one, x equal to pi upon 2, this is a line. And then y equal to sin x varies from 0 to this part only. And we need to find the volume of the solid generated by this line. So if we rotate, so a solid will be formed. So what will be the volume of that solid? We need to find volume of that solid. So first we observe here equation of curve is y equal to sin x. It is given equation of curve y equal to sin x and varies from x equal to 0 to x equal to pi upon 2. You know very well required volume means volume of solid generated by any curve. So here it is a formula. It is equal to pi into integral e to b y square dx. So e to b means values of x. If it is in terms of y, so we write here the values of the limit in terms of x. Here it is given x equal to 0 to x equal to pi upon 2. So volume, that is v, equals, we write here v, it is v, and v equals pi into integral 0 to pi upon 2 y square dx. It is a formula. What is this? It is a formula. Equals pi into integral 0 to pi upon 2 y square dx. Now just substituting the value of y square. So y sin x, therefore y will be sin square x. Y will be sin square x. And we need to convert. Here it is pi integral 0 to pi upon 2 sin square x dx. But integral of sin square x dx has no formula. So we should convert it in terms of 1 minus cos 2x entire upon 2. It is a formula 1 minus cos 2x upon 2 equal to sin square x. So pi into integral of 0 to pi upon 2, 1 minus cos 2x entire upon 2 into dx. When we apply cos 2x formula, actually this formula got from cos 2x equal to 1 minus 2 sin square x. So transferring it, we get sin square x equal to 1 minus cos 2x upon 2. Now integrating each term separately and to apply the limit properly. So this one is pi and this is upon 2. So taking 2 out of integral because of constant. So it is equal to pi upon 2 into integral of 1, that is x, integral of cos 2x is here sin 2x upon 2. Limit will be same 0 to pi upon 2. Now this pi upon 2 as it is, applying the limit, first we apply upper limit according to its rule. First we apply upper limit. So applying upper limit, we get pi upon 2 minus sin pi entire upon 2, because here pi upon 2 it is 2x. So 2 into pi upon 2, so 2 will be cancelled, we get sin pi entire upon 2 minus value 0. So x is 0, then it is 0. When x is 0, then sin 2 into 0, that is sin 0, and sin 0 is 0. So minus 0, minus 0. Now simplifying it, here it is pi upon 2 as it is, and it is also pi upon 2, but sin pi is 0. What will be sin pi is 0. So 0 upon 2 is also 0. Its value will be 0. So we have remaining term only pi upon 2 into pi upon 2. So this will be pi square upon 4. It is volume, so we should write its unit cubic units. So volume of the solid generated by y equal to sin x and x equal to 0 to x equal to pi upon 2 is pi square upon 4 cubic units. This is your correct answer, and you can choose in the competitive exam your option wherever pi square upon 4 is given. Now, you can write its answer in different form also, 1 upon 4 into pi square where it is given, so you should select that answer, or substituting the value of pi 3.14 and whole square of that part, so we get its answer in the decimal part also, so student can convert according to their requirements. So dear student, similar type of the questions, for the solution of similar type of the question, completion of the your syllabus and preparation of the competitive exam and tricky questions, watch my coming videos.